Hello, third grade, and welcome to Module 2 or Chapter 2 in Science, Electric and Magnetic Forces. So for Lesson 1, we're going to be talking about electricity. Have you ever taken off your hat and had some of your hair stand up? You know what made your hair do that? You might know that it has to do with one object rubbing against another object, but do you know what it creates when that happens? Let's go ahead and start our lesson. So you're going to open up to page 54, and you're going to read about Selma's hair. So you're going to read through this story and look at the opinions of the three different students over here. Write who you agree with most and explain why you agree with them. So we know they all had different ideas about why Selma's hair went up towards the balloon. You're going to figure out which one of them you think has the most correct answer. Once you've completed that, we're going to go over to our next page. We're going to look at the photo of the balloon and the girl's hair. What's happening to her hair and what questions do you have? Let's go back and take a look. So here's the picture of the girl and her hair. So take a minute to look at the picture, write down any questions that you have. Once you've completed that, we're going to read about the electronics technician. You're going to read this passage about this particular career and then answer the two questions on the following page. Why must the room be free of dust, hair, lint, and static electricity? Why is maintenance such a large part of an electronics technician's job? And then you're going to answer the question, how does electric force affect objects? So think about that from what you've seen so far and answer it as best as you can. Once you've completed answering these questions, we're going to go ahead and take a look at your inquiry activity on the following page. Now for this activity, we're talking about charged and uncharged balloons. So what does that mean? So we're going to do some investigating. You're going to explore what happens when charges between two objects are unbalanced. How will different materials interact with unbalanced forces? The materials you'll need for this activity are a permanent marker, balloons, paper plate, some hole punched paper or confetti, pieces of cotton cloth, paper towel, an acrylic sock, a piece of wool, like from a sock or a sweater. And then you're going to go ahead and answer or fill out your prediction. What occurs when charges between two objects are unbalanced? You're going to go ahead and carry out the investigation following the steps 1 to 7 on page 57. And then you're going to start recording the materials effects on the balloon. So sample A is your control. Sample B is when you rubbed it with the cotton, the paper towel with the acrylic, and with the wool. Circle the sample that had the largest charge. Underline the sample that had the smallest charge. Describe the sample that had the largest charge, so tell me about it. How did your observations compare with your prediction? Then you're going to construct your argument when you're writing out how your observations compared with your predictions. It was the same because, or it was different because, and explain your answer. Once we've completed all the questions related to our observation, we're going to take a look at our vocabulary. We're going to watch the static electricity video on how static electricity can affect objects, and then we're going to answer the questions. The question we're going to answer says, what example of static electricity was shown in the video? What effect did the static electricity have on the object? So you have two things you need to answer here on the lines. After that, we're going to get into our reading. So let's jump back over here to our slides. We're going to skip past the parts we already talked about and the inquiry activity. And we're going to take a look at our vocabulary. Static electricity is the buildup of an electrical charge on a material. Electrical charge is the property of matter that causes electricity. So electrical charge is what makes electricity happen. Attract is when things are pulled towards each other, and the word repel means when things are pushed away from each other. So a good example of this is think of a magnet. You'll have sides that will want to come together, and you'll have sides that no matter how hard you try to push them together, they'll push away from each other. Now, after that investigation, you should have a better understanding of the different materials that produce different amounts of electrical charge. What are some examples of materials that cause what are some examples of materials that cause two materials to attract to each other or repel? Once we've completed taking a look at our vocabulary, we're going to jump back into our book and we're going to read pages 254 and 255 in our science handbook and answer the questions. So our first question is, what causes electricity? Number 3 says, draw and label a diagram that shows the different combinations of electrical charges and how they interact with each other. Let's go ahead and answer those first. Let's open up our book. Static electricity. Electricity and magnetism. Electrical energy. Matter is made up of very tiny parts called particles. These particles have either a positive or a negative charge. Electrical energy is the energy of these charged particles. Electrical charge. You sometimes feel a shock when you touch a metal doorknob. This shock occurs because of electricity. If the room is dark, you can see a quick spark of light with the shock. A flash of lightning and the glow of a light bulb also occur because of electricity. The property of matter that causes electricity is an electrical charge. You cannot see electrical charge, but you can understand how objects with different charges interact. There are two types of electrical charges. One is called positive, and the other is called negative. The diagram shows how objects with positive or negative charges affect each other. So an object with a positive charge pulls or attracts an object with a negative charge. They'll want to come together. Objects that have both positive charges will repel each other or push away from each other. Same thing when you're trying to put two objects that both have negative charges. Those will also push away from each other. So you need opposite charges in order for those charges to attract to each other. Static electricity. All objects are made of charged particles. Most objects have the same number of positive particles and negative particles. The charges are balanced. When two objects touch, negative particles can move from one object to the other. Negative particles may build up on one object. The object has a negative charge. Buildup of electrical charge is called static electricity. A discharge occurs when static electricity moves from one object to another. This movement is why touching a doorknob can sometimes produce a shock. As a person walks across a floor, negative particles move from the floor to that person. These negative particles move to the doorknob when it's touched. A lightning strike is an example of a very large discharge. When you rub a balloon on a sweater, negative particles move from the sweater to the balloon. Then, if you hold the balloon near a wall, the negative charge attracts the positive particles on the wall. This attraction causes the balloon to stick to the wall. So think about static electricity over here. Static electricity, like we said, is a buildup of negative charges. So you can see over here in the picture of the balloon, there's a lot more negative charges than positive charges. When you look at the wall, they're about the same. But when you hold the balloon after it's been rubbed onto a sweater or on your hair or anywhere where it's building up extra negative charge, and you put it near a wall, it's going to attract or want to come together with the positive charges in the wall, and you'll actually see it stick to the wall. Now go ahead and answer the question about what causes electricity. Draw and label a diagram that shows the different combinations of electrical charges and how they interact with each other. So that's going to be this diagram down here with the positive and negative charges, and then the two positive and the two negative. Explore the digital interactive positive and negative charges on static electricity. Answer the questions after you've finished. Use vocabulary words to summarize what happened to the balloon. How does this relate to the inquiry activity, charged or uncharged balloons, that you completed? Let's go ahead and take a look at that video. So first, we'll watch the static electricity video. And then we will explore the digital interactive.
Hi, Malik here. Have you ever reached for a doorknob and zap, got a shock? Why does this happen? That shock is caused by static electricity. Have you ever come inside on a cold day, taken off your hat, and had your hair stand straight up? That's static electricity. Have you ever rubbed a balloon on your sweater and held it near a wall? What happened? That's right, the balloon stuck to the wall. This is also caused by static electricity. Static electricity is why some clothes stick together when you pull them out of the dryer. Can you think of other times you've seen or felt static electricity?
So these were all different examples of static electricity that you guys see and interact with every day. Next, we're going to take a look at the positive and negative charges in our digital interactive over here.
Click on the red pop tips to see how positive and negative charges react on the balloon. The buildup of electrical charges on an object is called static electricity. Rubbing objects together causes them to touch in more places. It produces more static electricity. A balloon and a wool cloth are neutral. Each has as many negative charges as positive charges. By rubbing the balloon with the wool, negative charges build up on the balloon. The negative charges on the balloon attract the positive charges on the wall. The balloon sticks to the wall.
All right, so take a look at what happened over here. We know that individually, the cloth and the balloon have their own positive and negative charges that are balanced. When you're rubbing it together, we're seeing a movement or a transfer of some of those negative charges. And we're seeing that buildup of negative charges in the balloon, when it's held up near a wall, attracts the positive charges in the wall, and it will stick to it, just like we saw in the video. So summarize what happened to the balloon in your own words and make sure you use vocabulary words. And then answer the question for number 5. How does this relate to the inquiry activity that you did, charged or uncharged balloons? What questions do you have about static electricity and the distance of objects? Next, we're going to investigate creating static electricity charges on a balloon with different materials by conducting the simulation. And we're going to answer the questions after we've finished. So we're going to have the item, the number of rubs, the distance from the paper, and our observations. And then we're going to talk about our conclusions, what conclusions we can draw or make after that. So we're going to select a material and the number of times a balloon is rubbed on that material. And we're going to use the slider to place the balloon at a certain distance from a hanging sheet of paper. And we're going to press the test button, and we're going to see if the balloon sticks to the paper or not. Let's look at our instructions one more time. We're going to pick the item, number of rubs, the distance from the paper, and the observations. Now you can do this as many times as you like. You don't necessarily have to do it as many times here. You can open up the website and conduct the experiment on your own. So first we can start with the woolen hat, and let's keep it at 2 feet, and we'll do 5 rubs. We're going to keep it at 2 feet. Let's keep it consistent for a little bit. And at 2 feet, we see that the balloon developed enough charge for the paper to stick to it. So we're going to reset it and try again. Now, what if we did the styrofoam plate? So again, we'll stick with 5 rubs. Now, what's happening is that the negative charges, there's a buildup of negative charges or static electricity in the balloon. We're going to see if there's enough of it to attract it to the paper. So over here, we can see that the balloon did not develop enough charge for the balloon to stick to the paper. What we can do is we can, if we want to see, we can try and increase it to 10. All right, so now with 10 rubs, we're going to test it, and we can see that the balloon still has not developed enough static electricity to attract to the paper. So let's reset and we'll try something different. We'll try the aluminum foil. We'll go back to our 5 rubs. And we will test it. Now you can see that the balloon did develop enough charge for it to stick to the paper. You can see the little red dots over here symbolize the negative charge that's built up. So let's reset. We'll try the glass. Again, we'll go with 5 rubs. We can see that some electrical charge is building up. It's increasing. It looks like there's a lot of it. So let's see if we pull it out to 4 centimeters away and see if it will still attract. And we see that it definitely did have enough electrical charge to attract to the paper, even from a distance of 4 centimeters, which is twice as much as it was before at 2. And our last one, we're going to try the wooden plank. We'll give it another 5 rubs. You can see that our electrical charge is building up in there. And similar to the glass, with just 5 rubs, there's a lot of electrical charge. So I predict if we put it back out here to 4 centimeters, that it will still attract. We'll go ahead and test it. We can see that it did develop enough charge to stick to the paper. We can go back over here. You would have been recording your observations from different distances. Write down what you saw, how much electrical charge did it develop, a lot or a little. Was it enough to attract or not enough to attract? What conclusions can you draw? Now, once you've completed that, for page 63, you have another inquiry activity about how to eliminate or get rid of static electricity. So you're going to use dryer sheets for this activity. And these are things that a lot of you guys would have at home. If you have a washer and dryer at home, if you have a dryer at home, you would use dryer sheets a lot of times to help get rid of some of the static electricity. So what problem does static electricity cause? You're going to write down your prediction over here. You're going to ask a question. What question do you hope to answer through this investigation? You are going to make up your own procedure and create a table to share your findings. And then you're going to answer questions about it, about what conclusions you can draw from the data. If you were to purchase a dryer sheet to reduce static electricity, which one of the ones that you sampled would you buy? Now, after you've completed that activity, we're going to go on to our next page, onto page 65, and we're going to read the handout about electricity in nature. And this is going to tell us about the different forms of electricity that occur naturally out in the world. And then we're going to answer the questions after we've completed the reading. So our questions are, how are lightning and static electricity sparks similar? How does describe how animals use electricity? And then you're going to make sparks of lightning using static electricity. You're going to write a prediction on how you're going to make those sparks. Now for this next activity on page 66, this is going to be an extra credit activity that you can complete at home. You'll need scissors. Polystyrene is basically styrofoam tray, some masking tape, and an aluminum pie tin. You'll have the directions over here and 2 questions to answer at the bottom. Summarize what you observed and then draw what you saw. So let's go back over here and read our handout on electricity in nature. What forms of electricity occur in nature? Electricity can be natural. Lightning is electricity. Lightning happens when electrical charges build up in clouds. These charges are released. The release makes a flash of lightning. Lightning strikes are powerful. They carry 30,000 amps of electric current. Your desk lamp carries 15 to 20 amps of electric current. Animals also make electricity. Electric fish light up the deep ocean. They attract prey to the light. That's how they hunt. Some fish use electricity to get food. Electric eels swim into a school of fish. The eels give off electricity. It kills the fish and the eels have dinner. Geckos use electricity to help them climb. Geckos have electric forces in their toe pads. A charge forms between a gecko's toes and the wall. It lets the gecko climb a slick wall. Your body uses electricity. Nerves use electricity to send signals. Signals move quickly. Nerves let your brain talk to parts of your body. Think about touching a hot stove. In less than a second, you pull your finger away from the stove. Your nerves sent a message to your brain. Your brain reacted. That message was sent by electricity. So let's go back to our assignment. How are lightning and static electricity sparks similar? And describe how animals use electricity. All right, that takes us to the end of our investigation over here. And the end of our lesson. If you have any questions, let me know, 3rd grade. Otherwise, I hope you have an amazing day. Take care. Bye-bye.